Ah, okay. Sorry. And my topic is basically about the potential of hybrid cooling strategies in office building to enhance energy efficiency. So basically, one of the main factors that influence indoor thermal comfort is the outdoor temperature, which can be as high as 45 Celsius in Saudi Arabia. This extreme outdoor temperature has impacted the overall energy consumption in the building sector by increasing the cooling demand to maintain indoor thermal comfort. The building sector accounts for 75% of the total energy consumption. Out of all type of buildings, office buildings make up around 17% of the total energy consumption. However, factors such as growing in population, developing economy, and rapid urbanization have contributed to the rise in demand for new buildings, including office building. Also, the high glazing ratio of office in the severe hot climate of Saudi Arabia will inevitably increase the higher rate demand and cooling load. And finally, previous research shows that the higher ventilation mode can achieve up to 23% energy saving in hot condition. So moving to the methodology, basically a simulation-based investigation carried out using IES tool on a selected case study office building, the National Commercial Bank in Jeddah City in Saudi Arabia, basically testing the hyperventilation approach, which is a mix of natural and mechanical ventilation on different floors, F1 and F2. So this system allows AC to switch on only if the indoor temperature exceeded 29 Celsius and the outdoor temperature is greater than the indoor temperature. And these basically the cases that I developed, starting basically I categorized them into three categories, starting from from group A, the existing condition, and then case 2, increasing the external insulation to 50%, and then following that, placing the insulation from the external to the internal layer of the wall, and then moving to group B, where I consider 40% window to wall ratio on the external facade. And then basically improving the window type to low E, and then adding louvers, and then also moving to last group, which is C, considering 100% window to wall ratio on the external facade, and then changing the window type to low E, and then adding louvers. So basically, this is the monthly energy consumption for both floors, F1 and F2. And as we can see that the highest saving is shown in the coldest month, which is from October to April, ranging between 9% to 30%, while in the hottest month from May to September, ranging between 4% to 8%, and there was not that much of differences between F1 and F2. However, when we look at the annual energy consumption for F1 and F2, we can see that F2 performed better than F1, and this is because that the orientation of the glazing in relation to the solar geometry. And out of all the 9 cases, case 6 performed the best, where I actually consider the 40% glazing and the low E window type, and the low E window type and louvers. And following that, case 6, case 9 also performed better, where I considered 100% glazing and low E type of windows and louvers. And this indicates that the shading device is actually effective in hot climate and reduce the energy consumption. So in conclusion, this study assessed the application of hyperventilation modes in the existing office building in Saudi Arabia with the aim of reducing energy consumption without compromising indoor thermal comfort. Case study simulation approach was used to examine the potential energy saving of the hybrid system using IES software. And under this hot climate condition of Saudi Arabia, the hybrid mode shows more energy saving in winter time than in the summer period. And finally, the findings indicate that applying some design strategies such as shading device on the building envelope resulted in a significant reduction of the energy consumption. That's it.
Thank you. I'm going to ask any question. Yes.
Thank you. Thank you for this presentation. I only had it up. I don't know if I missed it, but I didn't really get what do you mean while you're talking about the hybrid system. Can you get a bit more in the detail of it? And also, did you consider also the possibility of other strategies such as shadings or other things, or are they like completely exposed?
So I will answer the first question. So I didn't go in more detail about the engineering part of the system itself, but it's basically a mix of natural and mechanical system. Like whenever the indoor temperature exceeds 29 Celsius, when the indoor temperature exceeded 29 Celsius, the room just the windows close and the AC open, and so on. And for the next question again. What other treatment you said, like for the shading? It's louver. That's what I use. That blocks 75% of the insulation.
I do wear the previous one. Yeah, this one. Yeah, this one. I don't get the energy consumption in megawatts hour. They are higher in the lower in the summer than I would expected them to be higher in the summer. What's happening there?
The energy consumption?
Yeah.
In the summer, yeah, it's high, and the winter is low.
Okay, but the numbers. The numbers. Maybe I'm not understanding. The savings.
The saving number of the
Okay, because I was confused. Okay, thank you. And also, what do you mean by 100% window to wall ratio? Is it?
It's based on the trend of
the glazing.
Of the glazing ratio.
Okay.
Yes.
Understood. Thank you.
So is this a you explained at the beginning, it's an existing building, or is it
the base case, the existing building?
An existing building. So you consider, for example, some shading solution.
Yes.
And some internal, external wall insulation.
Yes.
I always ask, have you considered the cost of retrofitting and even the feasibility? Do you have the structural, external element to even support shading solution?
Again, your question?
So if you're going to put shading solution on a facades,
yeah.
You need to basically either create a twin facade, which is its own structural system independent of the building, or you need to make sure that the existing facade will enable the load.
The load, yeah. That's what I actually consider. It's the louvers is on the windows, so that's what I consider. Within the frame of the windows, yeah. Any questions?
Thank you very much.